And this video is going to go over the first 3 questions from our practice test. So the context is a psychologist studied the number of puzzles that subjects were able to solve in a 5-minute period while listening to soothing music. Let X be the number of puzzles completed successfully by a randomly chosen subject. The psychologist found that X had the following probability distribution. All right, so first thing I want to do is underline the definition of our variable. So they've defined X to be the number of completed puzzles. Okay. All right, next thing that I want to do is I just want to check to make sure that the probabilities add up to 1, right? So 20 and 40 is 60, 60 and 30 is 90, 90 and 10 is 100%. So yes, everything is looking good so far. All right, now let's look at the first question. Question number 1. What is the probability that a randomly chosen subject completes more than the expected number of puzzles in the 5-minute period while listening to soothing music? Ooh, okay. So this question mentions the expected number, which is just a fancy way of referring to the mean. All right, so I've got all this workable space here on the left. Let's calculate the mean of our random variable x. Now, the formula for finding the mean involves taking each value and multiplying it by its corresponding probability and then adding up all those terms. Okay. All right, so this is going to be 1 times 0.2 plus 2 times 0.4 plus 3 times 0.3 plus 4 times 0.1. Okay, I was going to try to do it without a calculator, but I might as well just do it with a calculator. So 0.2 plus 0.8 plus 0.9 plus 0.4 is 2.3. So now back to the question, what's the probability that a randomly chosen subject completes more than the expected number of puzzles, meaning more than 2.3? Right, what's the probability? Why don't I continue writing over here? What's the probability that x is greater than 2.3? Okay. Well, there's only 2 values here in this distribution that are greater than 2.3. It's 3 and 4. Okay. So that's 0.3 plus 0.1, giving an overall probability of 0.4. Okay, so we're looking at those outcomes right there. All right, so the answer to number 1 is 0.4. Okay. All right, question number 2. The standard deviation of x is 0.9. Which of the following is the best interpretation of this value? So when we're talking about interpreting the standard deviation, we want to make sure that we're talking about how values typically vary from the mean. Right. Or maybe we can first just start looking for an answer choice that has the phrase typically varies. Okay. So looking at choice A, it does not have that phrase. Looking at choice B, it does not have that phrase. Choice C says a typical subject, but it doesn't say typically varies. D says typically differed from the mean. And E says typically differed from one another. Okay. So already I'm liking choice D because it has the right language, typically differed or typically varies from the mean. So if we read the whole statement, the number of puzzles solved, so that's the context, typically differs, I prefer varies, typically varies from the mean by 0.9 puzzles. All right, that is the correct interpretation. All right, question 3. Let D be the difference in the number of puzzles solved by 2 randomly selected subjects in a 5-minute period. What is the standard deviation of D? All right, So why don't I do this? All right, let's continue to use x to be the number of puzzles solved by the first subject. I'll create a new variable y, and that will be the number of puzzles solved by the second subject. Okay. And then this new variable d is the difference. So that'll be x minus y. Okay. So d is the difference of two other random variables. Okay. All right. So we want to find the standard deviation of d. Now I'm wondering if there's something on the formula sheet that we could refer to. Let me quickly pull it up. It's right there. Yeah, no, I should have known. There's nothing on this formula sheet that will help us. There are some formulas, so you do have to kind of memorize them. Okay, so if we wanted to know the expected value of the difference, it would be as simple as finding the expected value of the first random variable minus the expected value of the second random variable. Okay. There is no direct way of finding the standard deviation of d, but you can find the variance. Okay. So the variance of a difference is equal to the variance of the first variable plus the variance of the second variable. Right. So we're going to focus on this. We're going to find the variance of d. Okay. All right. Now we know from the second question that the standard deviation of x is 0.9. And so if we square that, then that'll give us the variance of x. So 0.9 squared is 0.81. Yeah, okay. So squaring the standard deviation now tells us that the variance of x is 0.81. Okay. All right, so come down here, and we can go ahead and substitute that value, 0.81. Okay. Now, the variance of y will actually be the same as the variance of x, right? Because x and y are really the same variable. It's just x refers to the first subject, y refers to the second subject, but it's about the same context of solving these puzzles. Okay. So the variance of y will also be 0.81. Okay. So the variance of the difference is going to be 0.81 times 2, so 1.62. Okay. All right, let's label the left-hand side. All right. So we have the variance for d, but the question wanted the standard deviation. Well, it's a good thing we know how to convert variance back into standard deviation, right? You just take a square root to go from variance to standard deviation. So the standard deviation of d is the square root of 1.62, which is about 1.27, which is pretty convenient because that matches answer choice